Hello, I'm Jinzhu Wang. In this tutorial, we will go through this data process module. Let's open the VS Code editor and get into the Luto code structures. Here, the data module is inside this Luto subfolder. At first, we can see a data.py file. This is not how data was processed, but rather how data is stored in memory. The real data process happens in this economic subfolder. It has two main parts. The first is agricultural. The next is the non-agricultural. We can see they have very similar data structures. They both have biodiversity, cost, greenhouse gas, quantity, revenue, transition, and water. In this tutorial, we will use quantity as example to walk through how data was processed step by step. The quantity is where Luto to calculate the production of, for example, apples, rice, or meat fur from livestock. Single-click the quantity, all the code will pop out in the right screen. Here, the first function we can see is get climate change impact. Inside this function, we can find two key steps. First, it opened up the data of climate change impact. The next is it is interpreting this data. Let's walk through for each step. What are the looks of this climate change impact data? It is essentially a table. Let's go to this lutodata.figma link and search for climate change impact. So this data is opened in this command, and this table is how the data looks like. We can see each row is a cell ID, aka each row is a pixel or a 1 kilometer by 1 kilometer grid. For the column has three levels. The first level indicating if this pixel comes from dry land or irrigated land. The second column level indicating what is the land use type of this pixel. The third level indicating what is the year of the climate change impact. From here, we can say if, for example, if this pixel is beef, it will have some values. Otherwise, it will be non-values. The key takeaway for this table is for each pixel, we can get three attributes out of it. Whether it is dry land or irrigated land, its land use type, and the year of the climate change impact to this land use type. Back to the code, we can see here there is an interpolation applied to the climate change impact data. The effect is it will interpolating the 2020, 2050, and 2080 values to an annual record between 2010 to 2100. Back to our slide. We'll talk about data process. What this get climate change impact function trying to do is it interpret the three discrete values to the annual consecutive value between 2010 and 2100. Let's move on to the next function. Next function is get yield potential function. Here we observe that this bit of part we can see at 365. This is essentially to calculate how many grass each livestock, either sheep or beef, gonna eat for each year. Following this block is this function. Here we use the area of grassland to multiply the production, aka the kilogram per hectare of grassland. We multiply these two, we will get for each cell how many grass it could produce. And we divided this by how many grass each livestock will eat per year. So this will lead us to the yield potential. And the yield potential is how many head of livestock could a grid cell produce for each year. The key part for the get yield potential function is how we link the climate change impact into the potential. Here in the last line, we will first get climate change impact and then multiply the impact to the yield potential. Back to our slide, the get yield potential has done multiply the grass area by grass yield and divided that by grass per head. And in this way, we will get the livestock head numbers per grid cell. And more essentially, this function has linked the climate change impact to the get yield potential, so that we now are confident to say that when we're calculating the livestock number per grid cell, this number is impacted by the climate change. Following the get yield potential function is the get quantity of livestock. The key takeaway here is for livestock, we have to categorize the situation in different classes. For beef, we will calculate the meat production and the live export production of beef. For sheep, we will calculate the meat production, the wool production, and the live export production. If it is the dairy, we then only calculate the dairy production. The next function is to get quantity of crops. Crop production is much straightforward compared to livestock. Here, we rate this agricultural economic crop yield production data. And in the end, we only apply the climate change impact to the quantity of crops. Back to our slides, we can see the get livestock quantity production is to separating beef, sheep, and dairy into different products. Especially for sheep, it has 3 products: live, export, meat, and wool. However, for get crop quantity function, it only links the climate change impact to its crop yield. So that is a much easier situation. What's following is the get quantity wrapper function. In this function, if the production is a crop, it will activate the get quantity of crop function. If the production is a livestock, it will activate the get quantity of livestock function. Anyway, inside this function, it will loop through each product and get the corresponding quantity of the product. What's next is to helper function to get the final result. Here is the get quantity matrix. In this function, essentially, we just loop through each product. And what's following is the get quantity matrices helper function. In this function, essentially, we just loop through each land management, aka dry land and irrigated land. In the end, what we get is a 3D NumPy array. We can think of this as a 3-layer dictionary. The first layer indicating the land management, aka if this pixel is a dry land or irrigated land. The second layer representing the location of the pixel, aka in a map, where is the location or the cell ID of this pixel. Also, in the second layer, it will indicating the land use or product name of this layer. In the third layer, this is the value of the true quantity of production, which is in this pixel how much products in tonnage or in kilogram it will produce. Back to our slides. What we're talking about is the Luto's economic module of the agricultural submodule of the quantity, specifically quantity calculation. What it has tried to do is to create a 3-layer data. According to this 3-layer data, we can answer 3 questions. For each pixel, what is the product of this pixel, whether it's apple or livestock? What is the water supply of this pixel? And how much production is this pixel? More importantly, we also emerged the climate change impact into this get quantity module. So we can also answer the question that in the year, for example, 2016, what is the climate change's impact onto the quantity of each production? The similar logic applies to all of these submodules. For example, how we compute the cost, how we calculate the greenhouse gas emissions or abatement from each land use or land use management, and the revenue and the transition and water requirement for each land use. As a result, in the end of the process, we can answer the following question. For each pixel, under a given year, what is the biodiversity of that pixel? What is the cost and revenue of that land use or product? What is the greenhouse gas of this pixel given a specific land use? And lastly, what is the transition cost? For example, the land use transferred from apple to livestock, what is the cost of that transition? For both agricultural land use and non-agricultural land. When I say non-agricultural land, we have introduced some reforestation and some agricultural management. For each of these land use management, what is the cost, what is the implication of greenhouse gas, and so on. And all those data provide a base for Luto to optimize the future land use. In this tutorial, we have a close walkthrough of how data process was conducted in Luto model. Especially, we are using the quantity submodule to present how Luto will process the input data step by step and incorporating different aspects of impacts. In next tutorial, we will get into the solver and the simulation part to explore how exactly Luto was optimizing the land use.